Okay, this next section is very crucial to understanding the expansion of trigonometry that we'll do in this course, and that is reference angles. Okay, reference angles are used to help us evaluate these trig functions. We'll talk about them. Here we go in detail. When an angle theta is in standard position, okay, the reference angle theta sub r of angle theta is made by the terminal side of theta and the x-axis. Okay, now it's kind of difficult to maybe visualize, so I kind of generated this here. Let's just take a look. In green, you can see here is my theta. In red is its reference angle. Okay, notice here it's in standard position, and what we said here was its reference angle is made with the terminal side and the x-axis. So in the first quadrant, the reference angle is just equal to the angle in question. But as we move over into the second quadrant, okay, you'll notice here our actual angle theta, is bigger than 90, and its reference angle is here. It's made with the terminal side and the x-axis. If I take that down into the third quadrant, you'll see here theta now is in the third quadrant, its terminal side is here, and its reference angle is made with the x-axis. This is crucial. Common error is to draw this wrong. Okay, it's always made with the terminal side of your angle and the x-axis. So when we get here into the fourth quadrant, you'll notice this is actually the angle that I was given, but its reference angle is right here. Terminal side, and x-axis. Okay, so let's take a look at this. Reference angles in each quadrant. Alright, what we're going to do here first is we're going to go ahead and draw in green. I'm going to draw in my theta, okay, in each quadrant. Alright, this is our angle theta. There, it's in the third quadrant, and here it'll be in standard position in the fourth quadrant. I don't know what that is. Okay, that's our angle theta. And this is in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. Now, in the first quadrant, our reference angle in red is going to be the same as our angle. Okay, so, and we'll come back and talk about that. In my second quadrant, remember, it's made with the terminal side and the x-axis. Here, in quadrant 3, my reference angle is there, and in the fourth quadrant, my reference angle is made there. Okay, so let's just set up some kind of rules of thumb here. One thing that we need to make sure that we understand, because we're going to deal with radians, so I'm going to put this in radians and in degrees. But just as a general statement here, in quadrant 1, theta equals its reference angle. In quadrant 2, okay, the reference angle is going to equal 180 degrees minus theta, or pi minus theta, because that's in radians. In the third quadrant, my reference angle will equal 180 plus, it's going to equal theta. You can just look at the picture and see this. Minus 180, okay, or theta minus pi. Okay, and lastly here, in the fourth quadrant, my reference angle is going to equal 360 minus theta, or 2 pi minus theta. Okay, so it's not worth really memorizing these. It's more important that you understand them, so don't spend a lot of time memorizing them. Okay, quickly here. Find the reference angle for the given angle. Okay, well, 2 pi over 3. Some people want to convert that straight to degrees. I would say this. If you think of pi as 3 pi's over 3, then 2 pi's over 3 is 1 pi over 3 less than that, puts you in the second quadrant, and it actually helps you see what the reference angle is. If this is the angle 2 pi over 3, then there's only 1 pi over 3 left as a reference angle here to make it to pi. So you can think of it that way, or you can use the formula and say, okay, look, my reference angle in this case has to equal pi minus my theta, which is 2 pi over 3, which is going to leave me with pi over 3. And that is my reference angle for the angle 2 pi over 3. 290. 290 is here in the fourth quadrant. Okay, this is 290. Its reference angle will be right here. And what we can do is just say then a reference angle in this case is going to equal 360, because we're in degrees, minus 290. Okay, and so in this case you find out that your reference angle is equal to 70 degrees. Okay, reference angles play a huge role in understanding the graphs of sine and cosine, tangent, etc. As we go. Okay, now we want to find a point on the circle that is on the terminal side of 7 pi over 6. This is a crucial idea also. 7 pi over 6, again, if I think of pi as 6 pi's over 6, then 7 pi over 6 is 1 more pi over 6. So it's somewhere in here, okay, and we're looking for this point. Alright. Now, my reference angle then is a pi over 6. It's 1 more pi over 6 than pi. And if you look, I'll bring this triangle out here. This is a 30, 60, 90 triangle. Okay, where 30 is pi over 6. Okay, and really what we're looking for, again, this green point, is this point right here. And notice its coordinates will be the side lengths of the triangle. So, in this case, our side length, our x side length here, is the square root of 3 over 2, and across from the 30 is going to be 1/2. But what we have to realize here is that we're in the negative direction in both of them. So we want to consider these both to be negative, because this point right here, the x and y coordinates are both going to be negative. So our point on the unit circle that sits on the terminal side of this is actually at negative square root of 3 over 2, comma negative 1/2. Okay? And that's it for using reference angles for right now.